So in this class we are going to discuss about measurement of price elasticity of demand by a geometric method. So consider this figure 8, where a straight line demand curve, d dash is given, and it is required to measure price elasticity at point R. So this is a straight line demand curve, and we have to measure the price elasticity of this straight line demand curve d dash at point R. So how do we measure this price elasticity? So the geometric method is used to measure point price elasticity of demand. That is price elasticity of demand, when very small change in price takes place. So when there is a very small change in the price taking place, we usually use this geometric method to measure the, price elasticity of demand. So what do we do? Measuring price elasticity at a point, let's say R, on the demand curve by the ratio of the distance of lower segment and the upper segment at it is a geometric method of measuring point price elasticity on a demand curve. So what actually we have to do in geometric method while measuring the price elasticity of the straight line demand curve, let us say at point R. So under this geometric method we have to measure the price elasticity at point R by the ratio of the distance of the lower segment and again the upper segment at it. So that is the measurement of geometric method. We have to measure the ratio between the lower segment of the demand curve and then upper segment of the demand curve. So that is how we measure the price elasticity of demand through a geometric method, and geometric method is usually used in a straight line demand curve, or when we have to measure the price elasticity of a particular point which lies on the straight line demand curve, for example point R on d dash demand curve. So under this method the formula is given here. Price elasticity is given by RD dash, which is the lower segment of the demand curve, and then which will be divided by the upper segment, that is RD. So that is in ratio or proportion. We have to measure the price elasticity. So you will see from this diagram that the corresponding to point R, corresponding to this point R on the straight line demand curve d dash, price is OP and quantity demanded is OQ. Then price elasticity at point R, on the straight line demand curve d dash will be given by RD dash divided by RD. That is lower segment of the demand curve and then upper segment of the demand curve. So here we are going to prove the point of elasticity formula. So we have to prove the formula that we have discussed when we discuss the geometric method, and we will be referring to this figure number 8 again. So proof of the point elasticity formula. So how do we start the proof? So in the previous class we have discussed that the measure of price elasticity of demand is given by change in quantity divided by change in price into original price divided by original quantity. So that is the formula for price elasticity of demand. So the first term in this formula, that is change in Q divided by change in price, is the reciprocal, which means the opposite of the slope of that demand curve d dash. So change in Q divided by change in P is the reciprocal of the demand curve, that is D dash. Again, the second term P and Q, P is the original price, divided by original quantity. P is the original price and Q is the original quantity. So thus we have here, so price elasticity is given by 1 divided by slope, which means that 1 represents the reciprocal of the slope of the demand curve, because we have said that this, the first term in the formula, is the reciprocal of the demand curve, or a reciprocal of the slope of the demand curve. So when we say reciprocal, we have to bring 1 here, and then slope of the demand curve, and then this remains the same because this is the original price and the original quantity. So from figure 8, that is figure 8 here, what do we see? At point R, at this point R, the original price is OP and the original quantity is OQ. So, and OQ. So, slope of the demand curve D dash is given by, change in price divided by change in Q. We have to remember that slope of the demand curve is change in price divided by change in Q. So, and as we have discussed that this is the reciprocal of the slope of the demand curve D dash. So, slope of the demand curve D dash is change in price divided by change in Q, which is equals to change in price is PD. So change in price is PD, and then change in quantity is PR. So because OQ is equal to PR, and then PD is the change in price, PR is the change in quantity. So we substitute the value and we have EP equals 1, that is reciprocal, divided by, we are just substituting this value with this. So PR PD because reciprocal, into OP because OP is the price, original price, and then OQ is the original price. So further we have PR divided by PD, because we are just removing this one, PR PD into OP OQ. And again, when we look at figure 8, it reveals that PR equals OQ. So PR is equal to OQ, and they will cancel out. So we cancel out PR and OQ, and what we have is OP and PD. So at last we have EP equals to OPOD, because PR and OQ already cancel out, and what we are left is OP and PD. So now in the right angle triangle, that is DOD dash, so right angle triangle, PR equals, or OD dash, or PR is parallel to OD dash. In a right angle triangle, PR is parallel to OD dash, and when they are parallel, therefore we can draw the conclusion that EP equals OP divided by PD. So OP is equal OP divided by PD. So as I have said, when this PR is parallel to OD dash, when PR is parallel to OD dash, so when PR is parallel to OD dash, we can rewrite this OPPD as RD dash and then RD. So when PR parallels OD dash, OP equals RD dash. So OP is equal to RD dash, and then PD equals RD. PD equals RD. When this, DOD dash is a right angle triangle, and when PR equals OD dash, OP equals RD dash, and then PD equals RD. So in the diagram we can see that RD dash is the lower segment of the demand curve DD, and RD is the upper segment of the demand curve DD dash at point R. So hence we can prove that EP equals lower segment divided by upper segment. Lower segment is the RD dash, upper segment is the RD. Why we are drawing this conclusion? Because in a right angle triangle, when PR equal, or when PR is parallel to OD dash, OP equals RD dash, and then PD equals RD. Because of that, we are able to get this formula. EP can be rewritten as from OP divided by PD, we can rewrite as RD dash divided by RD. And hence we have proved the price elasticity formula, which is EP equals lower segment divided by upper segment. Okay, going ahead, we learn how to measure price elasticity on a non-linear demand curve. So the previous diagram that we had is a demand curve which is a linear straight line, but here this DD dash is a non-linear, it is in the curve form. So how do we measure elasticity when the demand curve is of non-linear in nature? So on the x-axis we are measuring quantity, on the y-axis we are measuring price, and O is the origin, and DD dash is the non-linear demand curve. So how do we measure this price elasticity, let us say at point R? So how to do? Now in order to measure price elasticity in this case, we have to draw a tangent at a given point R. So tangent, we draw a tangent line touching point R on the demand curve or on the curve DD, and then measure the price elasticity by finding out the value of lower segment and then upper segment. So here the lower segment is RT dash and the upper segment is RT. So we have to find out this lower segment value and then upper segment value, and we find out the price elasticity for this non-linear demand curve. So what will be the formula for this demand curve DD dash, which is a non-linear demand curve? So it will be, so the formula for this diagram or this demand curve will be lower segment divided by upper segment, and lower segment we have is RT dash, and then the upper segment we have is RT. So that is how we find out the price elasticity for a non-linear demand curve.